Lesson 9-4, Factoring to Solve Quadratic Equations. Alright, so just like last lesson, we're still dealing with a quadratic equation, meaning there's an equal sign and zero. We learned yesterday that we can graph and find the solution, so wherever the graph hits the x-axis are two solutions. And we can also do the square root. Now we only did that when there wasn't a b equaled 0, so we just had ax squared plus c. That's how we were able to do the square root. So that's not the case in this lesson, so we need to do a different method. Well, we're going to refer to the zero product property. Looking at the zero product property, if I have a and b and they're being multiplied and they're set equal to 0, well then either a or b has to equal 0 for that product to be 0. So they're saying if we have two binomials being multiplied together and it's set equal to 0, well, one of those then either x plus 3 equals 0 or x plus 2 equals 0. So we can set those two binomials both equal to 0 to find a possible solution to our quadratic equation. Let me show you what I mean. So in this example, they already have two binomials set equal to 0. We're going to practice finding what those two solutions could be. Alright, so 4t plus 1 and t minus 2 equals 0. Well, they're going to set each part equal to 0. So the first one is right here, 4t plus 1 equals 0. And the second part, t minus 2 equals 0. So when they're both set equal to 0, we can solve for t. So subtract 1, we get negative 1, divide by 4. T can be negative 1/4, or I can add 2 over here. T could be 2. Two possible solutions. Let me do another example. So two binomials, x plus 1 times x minus 5, they're set equal to 0. Well, I can set both of these, x plus 1 equal to 0 and x minus 5 equal to 0. Doing that, subtract the 1. X could be negative 1 or x could be 5. Two possible solutions. Alright, so let's back up a step. We're going to be given a quadratic equation that looks like this. Ax squared plus bx plus c equals 0. So to figure out the two solutions, we need to factor this trinomial. So here it is. They factored it into two binomials, so we're going to have to refer to our skills we learned last chapter. Once they have the two binomials, we can set them both equal to 0 to get our possible solutions. So let me show you an example. I'm going to do A. So I have m squared minus 5m minus 14 equals 0. Alright, I need two binomials that factor together to get this trinomial. I'm going to look at the product of 14. Two numbers that multiply together to get negative 14, well 7 and 2, and they need to have a sum of 5. Well, if I have m, and if I do a negative 7, positive 2, I'll get my negative 5 sum. Alright, so I can set both of these equal to 0. Subtract the 2. M can be negative 2, or add the 7. M could be 7. Two possible solutions for M. I'm going to do one more example. C is a little trickier. You have to remember how to factor when there's a coefficient in front of A. So 2a squared minus 15a plus 18 equals 0. Alright, we need two binomials. Before we can do that, we need to multiply the a and the c. That's 36. So we need a product of 36 and a sum of negative 15. Well, I know that 12 times 3 equals 36 and 12 plus 3 is 15. So let's use that. Alright, 2a squared, so you rewrite this. We rewrite negative 15a as, let's see, we need a positive 18, so negative 12a minus 3a plus 18. So we rewrote negative 15a as negative 12a minus 3a. Okay, so now I can group factor. So I'm looking at the first group. Well, I'm going to pull out a 2a. So I'm left with a minus 6. And over here, I'm going to pull out a negative 3. I'm left with a minus 6. So my two binomials are 2a minus 3 and a minus 6. Set those equal to 0. A, if I add 3 and divide by 2, could be 3 over 2. Or positive 6. My two solutions. All right, the last example is a real-world application problem. So you're constructing a frame out of wood for the rectangular photo shown. You want the frame to be the same width all the way around, so it's notated by X, 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 X. The total area of the frame and photo will be 315 inches squared. What should the outer dimensions be? All right. So to find area, I need length times width. We already know what the area is because we want it to be 315. So I'll just use my highlighter as we go here. All right, the length, so right here, well, the picture's 17 inches, but we're adding x on each side. So it's 2x plus 11. And the width going this way is our 11 inches plus, again, the 2x's on the side. So 2x plus 17. That multiplied together will get our 315 area. All right, so I'm going to multiply these with the FOIL method, and I get 4x squared plus 56x plus 187. To get 0 on the outside, I'm going to subtract 315. So this is an example from your book that I didn't exactly show you. Sometimes this won't quite be set into standard form. To get to standard form, we want it to equal 0. So all you have to do is subtract that 315 over. So now we have 4x squared plus 56x minus 128. So we just got it to standard form here, this one right here, by subtracting the 315. Now we have our equal 0. Oh, great. Now I'm looking to factor. Well, I can factor out a 4 from all of it, so I'm left with x squared plus 4x minus 32. From there, I create my two binomials, x plus 16 and x minus 2. They're both set equal to 0. Either way, when I divide by 4, 0 divided by 4 is just 0, so you can ignore that 4 on the outside. Set each binomial equal to 0. I'll get possible solutions of negative 16 and 2. Well, we can't have a dimension be a negative number, so this one's unreasonable. We're going to use just 2. So when I put 2 back into my dimensions, I get 2 times 2 plus 11. That equals 15, 4 plus 11. And my other dimension, so that's inches, is 2 times 2 plus 17, and that equals 21 inches. So my possible dimensions for my frame are 21 inches by 15.